Something came up through the Earth. Not down from the sky, not sideways through the atmosphere, up, from below. A radio pulse, captured by a NASA balloon drifting above Antarctica, arriving from an angle that physics says is impossible. That was the first signal. Years later, a detector anchored to the floor of the Mediterranean Sea caught a second one, a particle track of extreme energy, logged on February 13, 2023, designated KM3-230213A. Same impossibility, different ocean, different instrument, same verdict, wrong direction. Both signals point to neutrinos, the ghost particles of the cosmos. They carry no electric charge. They pass through solid matter the way light passes through glass. Almost nothing stops them. The largest neutrino detector ever built sits inside 1 cubic kilometer of Antarctic ice, listening without interruption for 15 years. Its answer to both signals, 0. Not 1. Not a marginal candidate, 0. On July 21, 2026, a paper signed by Dibya Chattopadhyay, Carlos Arguelles, and Vedran Berdar translated that 0 into a number, a statistical tension of up to 7.5 sigma. At 7.5 sigma, the probability that instrument error explains the contradiction collapses below any threshold science has ever used to declare a law of nature broken. The 0 is not an absence of data. The 0 is the weapon. Before we reach the silence, we need to understand what was heard. A sigma, first. Think of it this way. If you flip a coin and it lands heads 10 times in a row, you start to wonder if the coin is fair. At 3 sigma, roughly 1 chance in 1,000, scientists call something a detection. At 5 sigma, 1 chance in 3.5 million, they call it a discovery. 7.5 sigma means the odds of a random accident are so small they effectively cease to exist as an explanation. That is the unit of measurement for what is about to unfold. Now the signals. Between 2006 and 2014, a NASA balloon experiment called ANITA, the Antarctic Impulsive Transient Antenna, flying loops above the Antarctic ice, detected 4 radio events arriving from angles near the horizon or from below it. That is the impossible part. Neutrinos with extreme energy, energies above 1 trillion electron volts, the kind produced by the most violent engines in the universe, cannot pass through the entire bulk of the Earth. The planet absorbs them. Every model we have says so. Yet ANITA's 4 events behaved as though something had done exactly that, entered from one side of the Earth and exited from the other, producing a radio flash pointed upward. Then, on February 13, 2023, a detector network anchored to the floor of the Mediterranean Sea registered KM3-230213A, a single particle track, ultra-high energy, anomalous direction. 2 instruments, 2 different hemispheres, the same flavor of impossibility. Here is where the first hypothesis enters, not as an answer, but as the most reasonable door to try. If a diffuse flux of high-energy neutrinos exists, a background hum of these ghost particles spread across the entire sky, following a predictable power law, the same mathematical shape that governs everything from earthquakes to stock markets, then ANITA and the Mediterranean detector simply got lucky. They sampled a signal that is everywhere, all the time. Rare, but real. It is a clean explanation. It is testable. And here is the seed planted quietly at the bottom of this act. If that diffuse flux exists, if it is real, and it fills the sky, and it follows the rules, then the detector with 15 years of continuous data, 1 cubic kilometer of instrumented ice, and 5,000 sensors, waiting in the Antarctic dark, should have seen approximately 5 events, matching this profile. Approximately 5. How many did it find? That number stays locked for now. But the question has a name, and the answer will not be what the hypothesis expects. The station is called Amundsen-Scott. It sits at the geographic South Pole, on a plateau of ice 2,800 meters, above sea level, where the wind is constant and the temperature rarely rises above -25°C, even in summer. Beneath it, drilled into the ice between the years 2005 and 2010, lies the IceCube Neutrino Observatory, operated by the University of Wisconsin-Madison, funded across 17 nations, and expanded as recently as February 2026, in its first significant upgrade since original construction. The architecture is this: 86 vertical cables, each carrying 60 optical sensors called DOMs, digital optical modules, spherical glass housings the size of a basketball, sealed against the pressure of the ice. They hang between 1,450 and 2,450 meters of depth, where the ice is so ancient and so clear it functions as the purest particle detector material on Earth. When a neutrino, one of those ghost particles, strikes an atomic nucleus inside the ice, it produces a faint blue flash of light called Cherenkov radiation. Think of it as a sonic boom, but for light. A particle moving faster through the ice than light itself can, creating a shock wave that glows. The DOMs catch that glow. 15 years of data, more than 5,000 sensors, the most sensitive instrument humanity has ever aimed at the high-energy neutrino sky. Now eliminate the first suspect. The diffuse flux hypothesis, the idea that a background hum of high-energy neutrinos fills the entire sky, makes a precise mathematical demand. If that flux is real, IceCube cannot have missed it. 15 years of exposure, 1 cubic kilometer of detection volume. The calculation runs cleanly. Chattopadhyay, Arguelles, and Berdar ran it. Under the diffuse flux model, IceCube should have recorded approximately 5 events, matching what Anita and the Mediterranean detector found. The number locked in the previous act, IceCube recorded 0, not 1. Not a borderline case that the collaboration debated in a committee. 0 events. The diffuse flux hypothesis does not bend under this result. It breaks. So a second suspect enters. Perhaps the particles were not part of a continuous background. Perhaps they came from transient sources, brief, violent cosmic events, like a gamma-ray burst or a neutron-star merger, that fired a burst of extreme energy neutrinos and then went dark. If those transients fired exactly during the windows when Anita was aloft and when the Mediterranean detector was watching, and then went silent before IceCube happened to look in that direction, the silence could be explained without invoking new physics. It is a fragile hypothesis, but it is the last one standing. Chattopadhyay and his team did not dismiss it. They tested it. 100,000 Monte Carlo simulations, 100,000 synthetic universes, each one a different random arrangement of transient events, designed to measure exactly how much fine-tuning this explanation requires. The result of those simulations has not been spoken yet, but the number is waiting, and it is not kind to the hypothesis. On July 21, 2026, the paper was posted to arXiv under the identifier 2607.19487. The title is 4, 1, and None. The 4 events from Anita, the 1 from the Mediterranean, the None from IceCube. Here is what 100,000 simulated universes returned. Under the diffuse flux scenario, the tension reaches 7.5 sigma. 5 sigma is what science requires to announce a new particle exists. 7.5 means that in every possible version of a universe where the standard model holds, the probability of seeing detections in 2 separate instruments and absolute silence in a third is no longer a fluctuation. It is a structural impossibility. The transient hypothesis fares only marginally better. The probability that 4 favorable transient events aligned precisely with Anita's observation windows by chance is 1 in 10,000. Even granting that extraordinary coincidence, the residual tension stands at 5.9 sigma. Neither explanation survives contact with the mathematics. The 5 events that IceCube should have seen are not a theoretical preference. They are not a parameter that can be adjusted. They are the mandatory output of any version of the standard model, the framework governing every particle interaction ever tested, in every accelerator, in every laboratory on Earth. Any variation of that framework capable of producing what ANITA and KM3 net measured is compelled, by its own internal logic, to produce detections in IceCube. The absence is not a gap in the data. It is proof the framework cannot hold. This is the only answer the record permits. The only way to mathematically reconcile what ANITA and KM3 net heard with what IceCube did not is to accept that these particles do not obey the laws we built to describe them. The standard model does not fail at the edges, it fails at the center. In this file, evidence has a name: Archive 2607.19487. Chattopadhyay, Arguelles, Berdar, July 21, 2026. The case stands open. IceCube's February 2026 upgrade continues accumulating data. The Mediterranean detector maintains its watch on the deep sea floor. The next ultra-high energy track arriving from the wrong direction will not merely confirm an anomaly. It will either demand a revision of the most successful theory in the history of physics, or mark the first coordinate of whatever replaces it. The silence continues to accumulate, and in physics, accumulated silence eventually becomes louder than any signal.